Okay, so, one second. I want to make sure my phone is on silent. Okay, we're going to look at this problem. And I have to warn you, this is going to be another long problem with a few wrinkles along the way, but it's a very interesting problem. And I'll explain why as we go. But this is going to be our problem here. Standard equation, we're going to assume it comes from a flux f of u equals u squared over 2. But look at our initial condition. U of x0 is equal to 1 for x less than 0. It's equal to 1 minus x for x between 0 and 1. And it's equal to 0 for x greater than 0. Let me make sure I have my pages ordered here correctly. Okay. Actually, this is not the one that I thought was going to be so long, but there are wrinkles, and it will take a while to do. Okay, so I'm going to do something that I haven't done before, which maybe I should have. I'm going to graph what the solution looks like as time evolves. Okay, so over here, man, I just don't have enough room to do everything I want to do. So this is the x-axis. Okay, so this is the x-axis, and the vertical axis here is not the t-axis, it's the u-axis, the u of x-axis. I'm just gonna call it the u-axis. Okay, let's see if I can try to color code this. So what we're gonna have happen is for x less than 0, the solution is going to be equal to 1. For x greater than 1, let's say this is 1. For x greater than 1, the solution is going to be equal to 0. And then in between, I'm going to introduce a third color here. In between, the solution is going to be equal to 1 minus x. So it's like the linear interpolation between the blue and the purple solution here. Okay, and I'm going to draw several different graphs over here as time progresses. In the notes, I've done this all in Desmos. Actually, I don't know if I've... yeah. I should have, but I didn't. I thought I did put graphs here. Well, anyways. So I'll write the characteristic differential equations over here. So t prime of s is going to be equal to 1, and t of 0 is going to be equal to 0. X prime of s is going to be equal to 0. X of 0 is equal to x naught. Z prime of s is equal to 0. And then z of 0 is going to be equal to, let's say, 1, if we start there, is going to be equal to 1 minus x, if x is between 0 and 1, and it's going to be equal to 0 if x is bigger than 1. All right, so as usual, let's start drawing our characteristics and stuff. So this is the x-axis, this is the t-axis. Okay, we'll start with the leftmost characteristics. That's going to be the characteristics to start with x less than 0. Okay, so the characteristics to start with x less than 0, what do we know? Well, we know t of s is going to be equal to s. We know that z of s is going to be equal to 0. Z of s is going to be equal to 1 if we start over here. And, well, x prime is equal to z. Z is equal to 1. So x of s is going to be equal to s plus x naught. So I'll take this as a representative x naught. So these are just going to be lines of slope 1. So we're going to look at stuff like this. And then maybe I'll do one like this. And of course, as usual, this dashed line is the limit as x naught goes to 0. It's not technically one of these characteristics, that's why I drew it as a dashed line. Okay, Now, what I'm going to do next, I'm not going to do the green ones next. I'm going to do the purple ones next. So for the purple ones, over here, not least of which, because I'm going to have to use this same space to do both computations. So over here, T of S is going to be equal to S. Z of S, well, Z prime is 0. Z of 0 is equal to 0. So Z of S is equal to 0. Well, X prime is equal to Z. Z is equal to 0. So X prime is equal to 0. So we have X of S is just equal to X naught. So let's say this is 1. If this is X naught, we're just going to look at vertical lines like this. These are all just vertical lines. Okay. And then again, I will draw the border condition. Again, this is strictly for X naught greater than 1. So at the limit condition, X naught is equal to 1, I draw it with a dashed line. Okay. Now for the green guys, so for X strictly bigger than 0 and less than 1, we're going to have the green equations. So as always for these, T of S is just going to be equal to S. Well, I shouldn't say as always, because we just saw an example where it wasn't that, but we're always going to have S plus something, I guess, for these equations we're looking at for this part of the class. So X of S is going to be equal to, well, let me do Z of S first. Z of S, well, Z prime is equal to 0. Z of 0 is equal to 1 minus X naught. There should be a 1 minus X naught there. So Z of S on these characteristics is 1 minus X naught. And so X of S is going to be equal to 1 minus X naught, 1 minus X naught S plus X naught. I know green is not the best color, but the other, I've got 4 colors to work with. This is what we have here. Okay, so this says X of S is equal to 1 minus X naught S plus X naught. And notice what happens if you plug in S is equal to 0, we start at X naught. So let me just point out, these are going to be lines. The slope is going to be 1 over 1 minus X naught. So if X naught is equal to 0, we're going to have a slope that lies along the blue line. So in the limiting case here, we get a green line. We get a line going along the blue line. And in the limiting case where X naught is equal to 1, we get a vertical line. Okay, but in any case, the slope of these lines are 1 over 1, the slope of these lines, T prime over X prime, 1 over 1 minus X naught. And so 1 here, infinity here. But the other thing that I want to point out is that if you plug in S is equal to 1, that is T is equal to 1, since T is equal to S, you just get 1 minus X naught plus X naught, which is 1. So if T is equal to 1, X is equal to 1. In other words, all of these characteristics intersect right here, like that. Okay, so let me draw a couple of them like this. And then they, let's see. I need to draw it as, this is when I really wish I had like a yardstick or something to use. I should have prepared this ahead of time. Something like that. We're just going to go with that. Okay. And then something like that. These are all green lines here. Okay. And then, of course, the boundary, the limit conditions, X naught equals 0, are going to be along something like this. And then X naught equals 1, we're going to be going along this line here. So I'll sort of double them up like that. Okay. So let's step back and let's look at this for a second. Let's call this, well, we're not going to call it. This is T equals 1. Now, notice what happens if we look below T equals 1. We have no intersection of these characteristics. Okay? Because, yes, it looks like they overlap here and there, but that's not for X naught, those are the limiting cases, and they're not actually there. Those are just the limiting cases. So if T is less than 1, we don't have any intersection. when t is equal to 1, we start having the intersection in this wedge that we normally have. Okay, so again, for t less than 1, we have no intersection. For t greater than 1, we have the intersection that starts in this wedge right here. And now it's a little more complicated because the picture doesn't show that yet. But if I start a characteristic from here, let's say, notice now we have a point that's not lying on just two characteristics, but it's lying on a blue, a purple, and a green characteristic. Okay, so now we have to figure out, that's sort of the other wrinkle that we have in this problem here. Okay, so what's going to happen now is we're going to analyze this problem for t less than 1, and then we're going to analyze the problem for t bigger than 1. For t less than 1, it's like we're not even going to worry about any of the stuff that we've worried about for the past couple of weeks, and it's just like a problem that we've seen before. So for t, oops, let me shake my mouse. So for t less than 1, we're just going to do this as usual. I'm not even going to go through the steps because all we're doing is just normal characteristics. But I'll go maybe through some of the steps. So for t less than 1, okay, well, what is u going to be? Well, if we're over here in the blue characteristics, so this line right here is t is equal to x. So if we're in the blue characteristics, the solution is equal to 1, and this is going to be for t bigger than x, or x less than t. And if we're in the purple characteristics, the solution is going to be 0, and this line right here, that's x is equal to 1, and so this is going to be for x bigger than 1. When we have t less than x less than 1, so x between t and 1, well, the value of this, if I took a look at this x naught right here, the value of the solution there is 1 minus x naught. I know that on that line, x is going to be equal to 1 minus x naught times t plus x naught. If I solve this for x naught in terms of x and t, and plug it into that equation there, or to that expression, 1 minus x naught there, I get 1 minus x over 1 minus t. And this is for t strictly less than 1. Okay, so if I look at this diagram here, so I need to now figure out what's going to happen when t equals 1, and that's going to help me figure out, like, the first resolution, the first thing that needs to be resolved is I've got 3 different characteristics intersecting here. What do I do? What, like, if there's 3 characteristics, what is u left, what is u right? So I got to figure that out first. So I'm going to look at the graph. U of xt is equal to 1 minus x over 1 minus t. And I can see what's going to happen. So if this is the x-axis and this is the u-axis, and I'm going to look at, say, t is equal to 1/2, here's what's going to happen. I know I'm going to have my function is going to be equal to 1 for x less than t. So for x less than t, sorry, for x less than t, my function is going to be equal to 1/2, or equal to 1. So let's say this is 1/2 here. So that's 1/2. My function is going to be equal to 1 up until that point. Okay, now for t greater than 1, my function is going to be equal to 0. For t greater than 1, sorry, that's not 1. That's not that. Nope, wrong colors. For t greater than 1, finally, my function is going to be equal to 0. Okay, and now what I have, 1 minus x over 1 minus t, if t is fixed, and t is equal, t is equal to 1/2 in this case, this again is just the linear interpolation going down like this. Okay, so now we can see what's happening here. This purple is going to stay the same. Whatever value of t is, this is going to stay the same. And as t goes to 1, the graph of the solution, well, let's look for a different value of t. What's going to happen next if t increases a little bit? It'll be like this, and then a sharp downturn like that, And then if we look, in the limiting case when t is equal to 1, we're going to have something like this and something like that. So this is here t is equal to 1. Okay, and so now we see what's going to happen is that the shock, the discontinuity, is going to happen when the blue curve corresponds with the blue characteristics correspond with the purple characteristics, and like the green solution goes away. This is what the shock is going to. This is what the shock is going to be. Okay, so in other words, in this section right here, we're not going to have intersection with the green characteristics. There's just going to be intersection with between the blue and the purple characteristics. So we're going to have something like this. Let me get another one like that. Okay, all the blue lines are parallel and all the purple lines are straight. Like this. Okay. Alright, so now what we're going to get, let me draw the shock. Again, we don't know exactly yet what the shock is going to look like. But okay, so we have something like this. And so what this means is that the purple characteristics are going to stop when they run into the shock from below. So it'll look like this. Just get rid of this purple line altogether because it's not intersecting the characteristic the way that I have it drawn. And then the blue characteristics are going to also go in. Let me get rid of this dashed line as well. Okay. Just trying to clean this diagram up a little bit so we can analyze it. Okay, so we've got this shock. The black line is a shock. The purple curves, the purple characteristics are going to run into it from that side, and the blue characteristics from the left-hand side. Okay. And again, I'm just drawing the shock like this. This is probably not what it's going to look like, but it's just sort of generic curve. Okay. So again, purple shocks from blue shocks from the left, blue characteristics from the left, purple characteristics from the right. Okay, well now we can use the RH. So xs prime of t. This is the derivative of the shock location. Well, remember for the standard Burger's equation is just UL plus UR over 2. UL is equal to 1. UR is equal to 0. So we divide by 2, which is equal to 1/2. So x prime is equal to 1/2. X at the shock velocity is equal to 1/2. So we've got xs of t is going to be equal to t over 2 plus c. Now it starts here when x is equal to 1 and t is equal to 1. So if I plug in 1 over here and 1 there, I've got 1 equals 1/2 plus c. In other words, c is equal to 1/2. Okay, so what I'm going to have then is a slope, a line whose slope is equal to 1/2. A line whose slope is equal to 2. So it's x is equal to t over 2 plus 1. The slope of that line is going to be equal to 2. Okay, so let's just go back to this. Okay, so we're going to have a line of slope 2. I just want to make sure that I've done everything correct here. Yes, okay. All right, so now we're going to have a shock that looks something like this. Okay, so remember the other dashed line goes up that way, and so this is in the sector that we need it to be in. All right. And so now we're going to have something like that over there. And we're going to have something like this. These blue lines all have slope 1. I don't know if that's actually true or how close that is. Obviously, it's not actually true. But, I mean, actually true in the sense of, am I drawing them correct? Okay, and so now this is for t less than 1. So for t greater than 1, u of xt, and really this is for t greater than or equal to 1. For t greater than or equal to 1, u of xt is going to be equal to the blue characteristics to the left of that line. So it's going to be equal to 1 if we have, if we're to the left of this line. In other words, if x is less, when I say less to the left of this line, I mean left to the left of the black line. There's going to be x is less than t over 2 plus 1/2, and it's going to be 0 if x is greater than t over 2 plus 1/2. Okay, and this is the complete solution to this problem.